This is Jeff. We met each other, well, we were office mates for a couple of years at NYU doing astrophysics. So our day jobs, and your day job still is, doing astrophysics around ultra-high-energy cosmic rays, which is fairly unrelated to mapping civic data in D3, but you know, that's how these things go. We jumped in on Big Apps this year, which proves that you do not have to be a media web developer to jump in on Big Apps. There were three physicists that got involved in that. And what we ended up doing together was an interactive website of electricity data in New York. And did some analysis work analyzing electricity use by population, by number of households, by median income, which is a really interesting metric to look at, it turns out. And so through that, we met Vivian at the Beta NYC meetup around Map Pluto, which is a big tax lot data set. But this is the map that really got us into all this trouble in the first place. So this is a nice interactive map where you can mouse over any zip code in New York. It'll give you the particular number you're looking at, so in this case kilowatt hours per person. You can change that with the drop-down menu. The colors beautifully animate because D3 is amazing. And allows you to get an idea of where the hotspots in electricity use are in New York City, where people spend the most money on the largest percentage of their income on electricity use. So in this case, Hunts Point up in the Bronx is the highest percentage. If you go mouse over, you can see 9.3% of income gets spent on electricity there on average, whereas somewhere down, that's 1.3% of income. So this was a fun project to put together. It involved a bunch of data analysis on the back end to bring in census data and a load of other sources, and then to work on the front end is to bring all this into one place and putting together a nice vision. And this was very much our first kind of mapping project with D3. So we were very pleasantly surprised when we got featured in the Atlantic, which shows that one thing is always true. People really like nice maps. And with D3, it's incredibly easy to make nice maps. So over the course of the evening tonight, I'm going to walk through each of the steps that went into this. And I'm going to turn it to Jeff and walk through some of the steps that go into adding Google Maps underneath it, which is what we've got in this one. So that's when you can rebrand, you've got all the roads underneath, and Google does. It adds a whole layer of extra information underneath it, which is a nice thing to have. There is a Git repository which has all of this on it, and you can go on there, do a Git pull down the data. You can easily just go to the GitHub webpage. You can click download as a zip file, and it'll just download a folder to your computer. If you don't want to actually check out the code with Git, you can just download it instead, and that will give you all of these different websites that show the iterative progression to get to a map like that in there. It also has all the slides from tonight, so you can look at both the slides we've got for D3 stuff and the slides we've got for bringing in the Google stuff as well. So hopefully you should be able to get a local copy of that all up and running on your machine without any trouble. Feel free to either sit back, relax, not do any coding, or pull down that data and have a look at each of the files as we kind of walk through. But I'll have both up so we can look at the source code. And this is supposed to be at some level interactive, so if you run into problems, if you have questions, if things just aren't working at all, we'll try to answer the questions you've got. And remember, we're physicists, not D3 developers, so we'll do our best. Yeah, quick show of hands. Who here has used D3 before? Okay, who here has done mapping with D3 before? Okay, you guys get to help answer questions. Right, okay, and so there's about 50% of you who've never used D3 before, have heard about it, roughly know that it's that thing, but Okay, that's great. So I'll walk through some of the concepts as we go through when we start into this as well. Cool. Okay. Yeah, I'll swap over and Jeff can do the Google stuff later on, but he can also answer questions, so I'll send him around if people have stick their hands up. Okay, so the first thing with any map is you want to find a location that you want to map. It seems like a simple thing, but actually that's kind of the core thing to start off with. The stuff I'm doing here is all to do with New York City. There's some great sources for shape files and data for New York City, and there's loads of excellent open data that you can keep to the New York City map files. So what you need for the core of a D3 map is you need something called a GeoJSON. Now, a GeoJSON is like a JSON, but with a particular format structure, where it has both the actual SVG outlines of the different polygons built into the JSON. Then it also has a feature set, property set, which gives you details on each of those SVGs. Okay? So basically, what you end up with in a GeoJSON is a list of SVG elements. Each one of which gives you a bounding box and also has data flagged to it. And there are some great places to go to get hold of that. There's a website called Media Cities. It's a New York-based company. They've taken a lot of the shapefiles that exist for New York City, and they've taken them from Esri shapefiles, which are going to be familiar to people with a GIS background. Esri does a lot of stuff with ArcGIS, and those are kind of, it's a semi-proprietary format, and you do find software which will parse those, but it means that to use something in JavaScript, then you need to be able to take it from the Esri shapefiles into GeoJSON. These guys have done it already for some regions, so in this case, here are your outlines that you can pull down from there, so you just go there and download the shapefiles from there. If you want to go elsewhere, I've put up, yeah, there we go. So when you pull down the D3 mapping GitHub file, that will allow you to actually get hold of the GeoJSON outlines for the zip files, for the zip codes that are being used for the project. So they are there, they're just in the data folder. So in data, there you go. There's a zip code, GeoJSON there, and then there's a couple of data sets, which are going to just use to talk through and get something right. Okay, for other outlines, if you Google the GeoJSON and the thing you're looking for, you will often find that somebody's done it for you already. If you need to get hold of GeoJSONs, but all you can find are shapefiles, then the guys at Media Cities are great. You can just always send them an email and they will pass them, spit them back over to you, and also post them on their site. You can equally email me. It's like a 5-minute job to open up a shapefile in QGIS once you've got QGIS installed, and then just export from there. So, if you can only find this your shapefile, the program you want to find is called QGIS. That's a free parser which will read in all Esri shapefiles. You can load the shapefile to QGIS, and then you can just right-click on the shapefile layer here and do save as, and it just exports to GeoJSON and all your problems are solved. As well as outputting the SVG outlines, it will also keep all of any data that's tied to the object. So in this case, this is a map of the electoral districts in New York City. As well as them being outlines, each of those has an electoral district ID, it has a bunch of electoral district information tied to it. When you export to the GIS, all that information is there, and all that information can then be pulled straight into D3 without any trouble at all. So, that's just a tip for knowing that. Okay, but what we actually want to do is build a map. So let's start, as we start with all D3 projects, we go straight to D3 examples and we steal the thing which is closest to the thing we're looking for. Now, 50% of people in this room don't do D3. This can be solved in about 5 minutes by doing exactly that. So let's go to D3 examples. This is one of the greatest resources So here are every data visualization you're ever likely to need, and a large number of data visualizations that I cannot imagine you ever needing. If it's not in here, I just don't know what it is you're trying to do, because this is a phenomenal resource. So, like, for example, there's a whole set of zoomable maps, and you can just load this up. And this is a great resource to go to when you want to dig into stuff after this session. But for example, here is a zoomable map, which allows you to zoom in and zoom out by clicking on different locations. This is going to look awfully familiar if that happening. But what we're doing to start off with is we want to find a nice choropleth map of the states. There we go. So this is an absolutely classic choropleth map. It's taken counties, I think, in this case, and it's tied the color of the county to a quantized scale. So it's a set of colors from light blue to dark blue, which is mapping some particular property of the county. And then you also have these state outlines here. Now that's a pretty complicated thing to plot. If you wanted to start just creating JavaScript with HTML to build this thing, that's a heavy-duty piece of work. Wonderfully, copy and paste is a very quick thing. And you can see here, like, this is the full extent of the script. Okay? This is why this evening's work is going to be very, very quick. And then we're going to have time for questions. Because literally, when you can fit an entire choropleth map on one laptop screen, okay, that's it. That's the whole thing. There's really nothing in here which is particularly complicated, and it renders that beautiful map for you. And every single one of the examples on the two examples page has all that text right there. So you can do this with any of those examples. You can go in there, you can copy it, you can paste it. It's not even illegal. You don't even have to feel bad about yourself. Mike Bostock's paid by the New York Times. He doesn't care that you're copying his work, so it's fine. But I'll just walk through quickly what is in here, just to prove you can just copy and paste this. Here is the same map. You'll notice this now running on my own local sandbox server. And JSandbox, please remember index_US_1. Okay? You can even just download this straight to your laptop. You can copy and paste it straight into an HTML document in a raw text editor, and you can double click it. And it's almost certainly going to actually just work. You don't need a server running. There's very little of it. You can run it locally when you aren't even on the wireless. Okay? You can open this stuff up on there. It's all being mastered by your browser, and your browser doing all the heavy lifting. Yeah, so there's one particular exception, very glad to call that out, which is that what it does is to create the outlines, it does a load with the JSON. So it pulls in a JSON, and that's an AJAX request. You need to be running a local server to do that. You can get around it by just changing your .json file to a raw JavaScript file, and just say in the JavaScript file var map equals the entire data structure, and then you just include it as you would include any JavaScript file, and that means you can get around the if you begin to run your server to any case. But so this is exactly how it's running on the server. You have a bunch of style information at the top. So this is just telling you that we want counties to have no fill to start off with. We want states to have no fill. We're styling the SVG elements using CSS. So any CSS will be familiar. You just pull this in, and this is your style sheet which sets the bulk properties of your whole map. Okay? There's some unfamiliar things in here because these are setting SVG properties rather than your classic CSS properties. So if you're dealing with text in D3, you're not going to set font color. You're going to set stroke color. Little things like that will catch you out, but just remember that when you're using your overall style sheet, you're setting SVG properties. And then this is just a quantized scale. This is what sets the scale of loose. Yes. Oh, yeah, absolutely. Better? Great. Okay, so that's the style sheet. There isn't anything in there, I think, which is going to be particularly surprising. So in this case, this is just setting a white scope for the states. So that's what's giving you these white lines for the bounding states there. That's the full style sheet at the moment. There are 3 things being loaded in to help run this. D3 itself, we do need D3 to get this to work. A queuing thing which basically loads the JSON, and then as soon as the JSON is loaded, fires up another routine to actually do the coloring and plotting and all the rest of it. You mostly don't need that, but it's in the default code, and I'm literally copying and pasting at this point, so nothing interesting has been done. And then a topo.json, which basically is just a lighter weight version of GeoJSON. That's all that is. In most cases, you don't need the topo.json library. In this case, because we're stealing this code directly, we do, because it's loading topo.json to GeoJSon. Okay, any questions at this point about the code structure? Good stuff. Right. Next thing, we set some global properties. In this case, we're setting a width and a height. That's just the box that we're putting up. That's what those properties are. And we are setting up a rate by ID, which equals D3 map. This is not the map. Okay? This is a map that maps between a number and a quantity. Okay, so this is how we're going to end up fitting our data to say we have some smooth range of data, but we want it to fall into specific quantized bits to give us our colors. That's what that is.
Is that just scaling?
Yeah, it's basically going to take the scaling and fitting. And this is a path object, which is basically what tells it later on when it reads in a GeoJSON, it's going to turn that into a geograph. So that will come in a second. Here's where the core of the work gets started. So we set up a global object called SVG. We use the D3 select to find the body element. And a D3 select is exactly the same as a jQuery select to all intents and purposes. You're passing it all the same select as you would expect to pass into jQuery. So in this case, it's just selecting the body element. It's appending a new SVG to that, just creating a DOM element to go in there, and then setting the attributes. So dot attribute sets the width and the height attribute there and there. So you can use this exactly the same piece of code to set fill styles, to set CSS colors, set classes, all that kind of stuff. This is a really useful worker routine where you can, if you've forgotten a specific D3 command to do something, like .class and then set a class and set it to true, you can usually say .attribute and then just put whatever you think you need to set and get there, or get to, so it'll both set and pull the information you need. So that gives us just our blank container SVG. Then at this point we use this Q command that got brought in from the library. What this is saying is load the us.json object. So that's all of the county boundaries, all of the state boundaries. And also load the unemployment TSV file. So it's saying pull in these two sets of files and wait for them. And once they've been pulled in, then call the ready function here. Because JavaScript is asynchronous, which is great most of the time, but real pain the rest of the time. And then what we do is we actually write the ready function. So this is the point where we actually draw the map. So once those files have been loaded in, then we call the ready function, we call the ready function with these arguments. We append a group element. So this is just an abstract container, which is going to hold all of our individual SVGs. We're going to set that group to have a class of counties, so that we can easily get a hold of it later on with our selectors. So now that we have a group and has a class of counties, we can do a d3.select brackets g.counties, and we'll find it. We can easily find it, and then we can label it there. And then we're going to select all paths. Now we haven't got any paths yet. So we know that this is going to return an empty set, okay? But this is one of the little quirks of D3. You always start off by saying, give me everything that's there. And then when it routinely returns nothing, then you add stuff to it. No, you always start off by saying select all, of a particular type. So then this gives us an empty set of paths, We then use the .data object. And this is really the core magic of D3. So D3 is data-driven documents, so it's not surprising that the .data is the key part that drives a lot of this work. And in this case, what we're doing is, so the data function will tie a data object to whatever HTML object you've already selected. Okay, so in this case, the thing we've selected is this big group of paths, of which there are no paths. We're tying a data object to that, which is a GeoJSON of counties. Okay, so this is taking the top JSON, looking for the feature, which is the us.objects.counties.features. That's basically just drilling down into the JSON until we get to the particular list inside that JSON we need. That's all we're doing here. There's a bunch of other stuff in that JSON we just don't want. So this is just drilling down to get a particular list of counties. And we're tying that list of counties to our empty set of paths. All we're doing at this point. So that's now all tied up, it's hooked together. Now we need to do something with it. So that's what we call the enter function. So the enter function is the last kind of really generic piece of D3 magic that happens here. What that says is, if your initial set and the new set you now have having tied the data to it are different, find all of the things in the new set that don't exist in the initial set and iterate over them and do a set of operations on them. So all of this is saying, like, say we already had Iowa in our map, and we tied the whole set of all states to it. So now we have everything as well as Iowa. What I would say is, here, I know about Iowa, I don't need to worry about it, I don't need to do any operations on it. All that data is exactly as I saw it previously. But I have all these new states, and I need to do something with those. So what it'll do is it takes that set that it doesn't already exist in the previous selector, which we got to here, and it says, okay, all of those now form our enter set. Okay, so now we're going to loop over that enter set, all this new data that's suddenly been brought in, and we're going to do all these things to it. So you'll see this is a very generic piece of D3 code, which is that you find yourself an HTML selector, you select everything that matches it already, you tie a bunch of new data to it, it then figures out which of that data is true view and which it can just simply ignore. And then you run the enter function on all that new data. So what we're now doing is, okay, this is all new, so we don't need to do anything fancy. We're going to take, so this enter function is now an iterator. Okay? So there are no for loops. What this is an implicit for loop which goes over all those new data objects and does something with them. So in this case, for each one, you have to implicitly put the for loop in your mind when you read it. For each one, append a path to this set. We have our empty set, we're now throwing in new paths. And then give each one a class. So we're giving it a class which depends on this quantizing. So in this case, we are using the rate by ID function to get a particular, to get the d.id element out of the data set. So it's pulling in some element there, and it will return a class. Now, the tricky thing here, and the one that's a really, really useful feature of D3, is this letter D, which comes in right here. Okay? So anytime you see that, what it's really doing is the D stands for the particular data element that you're currently on in your edge. Okay, so we've added a bunch of new data. We're now looping through all that data because there's this implicit for each that's happening on the enter function. And rather than just saying, set class to county for all these things, we now actually want to do something which is dependent on the individual properties of the individual element we're looping over. So we need to get the individual element we're looping over. This is exactly how you get the individual element you're looping over. So D here is the data element. So in this case, this is the individual GeoJSON for the given county that we got to earlier. So what we do here is we function D, and then we return a class which we got to by calling a function like this. So the d.id is the ID of the individual county that we're looking for. And this means that if you tie any data to any GeoJSON that you're pulling in, you can do work on it. So you can tie population data to one of your GeoJSONs. And that means that you just call d.population, and suddenly you have a population value for the individual state. You can call d.electricity use, you can take ratios, you can say d.myhome, and have it Boolean, yes or no. So you can do all of those things in there. So what you want to do, or the way we did it, was we pre-processed all of the data into GeoJSONs in Python and a bunch of other analysis software that we ran totally offline. Then we had our stripped down GeoJSON, which had the actual key information we needed. So when we draw the map, it's just looping over, and when you change from one metric to another, it's like, oh, what is the ratio of your median income, which is being spent on electricity in the zip code? So it's just d.ratio of median income, or some much more abbreviated term that we use for that. Yes.
If it is that the map is static in the sense that it's a snapshot of the data that is on time.
Absolutely. And there is nothing to stop you from putting an external function call in that loop. So, for example, say you're looping through zip codes. As you loop through the zip codes, you're actually getting the individual zip code IDs in there. Now, if there is any API out there which you can query with the zip code, you can query it right there. And because JavaScript's asynchronous, it will just queue up all of those API calls. Somebody might shout at you and try to hit the API with every single US zip code every time you do a map refresh, but that's on them, not on you. But you can hook all that stuff up in there, and that would make it dynamic. The other way to do that, of course, is to have two separate data structures. So you have one data structure that you load in, which is your map, that has the key ID of the element you're looking at. And then you have another data structure, which is like a TSV or whatever, that you can swap between, and just pull that out and push it in and change it over depending on what happens. So you, in this loop here, you would say, give me the ID of the thing I'm looking at. Now I'm going to query this other JSON data structure that I have in memory that can be swapped out or in at any time. And then finally what we do here is we set the attribute D to be path. Okay? This is an incredibly unhelpful line of code, but it's absolutely fundamental to what's going on here. So D is the thing which actually draws your SVG. Of course you would know that. And path isn't a path. Path is this object up here, which is actually a function call to the D3 geopath object. Okay? So what's really happening here is the D3 is saying, right, let's take this data object, let's take this GeoJSON. I need to know how to draw this, I don't know how to draw this, it's a JSON, not an SVG. It then passes it as an argument to the D3 geopath, which will output the actual text SVG string. Okay? That's what happens there. You've never heard it once, you never need to worry about it again, just remember to put that call in bottom, or you do all this lovely work and you don't render a damn thing, which is terribly depressing. And that's it. Okay? That's the whole lot. That's the ballgame, we're done. And the last thing here is taking, this is doing all the counties. The last bit here is doing all the states. So the last thing is doing exactly the same thing, it's just creating SVG elements for states. Okay? So, the argument that's passed into function with D, there, so function brackets D is just a standard piece of D3 structure. You could give it another name because you're assessing what it is in the argument that you're calling it. So G is a special letter because so your heading GG defines a group. So it's D3's group structure. So you set up a group and you can throw lots of elements into that group, and then you can add the whole group together rather than adding only elements of the group. Which is extremely useful if you're doing pan and zooming, because if you act on every single element within a group with a zoom and pan process, that's highly intensive. If you just do a transformation on the whole group at once, you can make your life 100 times easier and make it less responsive. So that's the reason why, even beyond just organization structure, having group elements in there is really handy. Okay, so that's it. Congratulations, we've now created a D3 map. We're done tonight. Yes.
If you just commented out the second defer, would you just get a map of the United States by state?
Yes, and basically what would happen is that so we're using the unemployment data to populate the color. So if you comment out that line, you should still get a map of the United States, but it will have zero fill and all the lines will be white. So it will be there, it just won't look like it's there. But you can totally change that by setting the background to black or by setting your stroke color up here to be black rather than white. And it should pop up again. You'll probably throw some JavaScript errors because you're probably expecting some of that data somewhere, but if you comment those lines out as well, you'll still get a nice map in that sense. Okay, so that is boss.corp, which is our starting point. And so, in case people weren't taking notes or you just want to go back and read this over later, here's basically a note of what each of those lines actually does in the code. And you can comment it out and try and run it and see where it fails, and this should explain what's going wrong if things break. Yes? Okay. How badly did it go?
Well, I said the fountain red and it's these weird lines where it's hard to say.
That's awesome.
You can Google that. I've seen that. It's not reading the last of the geometry, and that's why I've seen that in some Stack Overflow questions.
My suspicion is to do with the fact that there's a top of JSON. So a GeoJSON and a top of JSON are slightly different things. They're both encoding geo information in SVGs. And the difference is that basically, okay, we've got all these GeoJSONs, each of those is an individual SVG element. Every single line on every single state boundary apart from the coastline is duplicated in that information. So it's a total waste of space if you can actually have lots and lots and lots and lots of SVGs. So top of JSON should include all of those lines just once, which is, I'm pretty sure, why that breaks, because it's connected. It's not taking each of those as an individual isolated element. It's actually hooking each of them up to that. So I believe that that's exactly what you're seeing on here. It's just that here there's no fill. And so the counties are the only thing that are filled. And the states aren't filled, but if we fill them, I'm pretty sure we see exactly what you see. Okay.
It is pretty amazing.
Yeah. So yeah, we can just go straight in here and we say let's fill the states. Let's just fill it with red. There we go. Yep, it does exactly that. So I think at this point we will legitimately say that them setting fill to none was a good idea. So there we go. We're now getting rid of filling states. Right, but now we actually want to go to New York. So let's take a quick look at building a New York map. Right, to update the map to New York City, what do we need to do? We need to change the data structure we loaded. So whereas before we were loading in the US.json structure, now we're loading in the NYC zip code.json structure. So either you download that to the same data folder on the GitHub, or you just point your own instance of this code at JSandbox/bpmapping/data/NYC zip code JSON, and it will load it in just fine, because you're doing an injection call against my own dev server. So we do exactly what we did before. This is just setting up the SVG element, setting the width and the height. That's identical to what we had before. And I've now deleted the TSV load line because we're not loading in any TSV data here. So all we have is the D3.json loaded in NYC zip code.json. So it's just doing a load of a zip code GeoJSON. All that's happening now. And then the ready function is exactly what we had before. So it's now saying create for the SVG that we have, which we built already here, append a group. That class is called counties. It shouldn't be called counties, we use now zip codes, but I really didn't change much to get this working. Select all paths, again we have no paths. Attach the map.features element, that is just a list of zip codes. You could open up the JSON to see what that is, but that is just a list of zip codes. And then enter for each one, append a path, and call the path function on the GeoJSON element. On the right hand side is just the actual listing of what the GeoJSON looks like. Okay, so this actually shows you what the GeoJSON structure looks like. We have a list of features. So this is the zip codes.features element. So you get the reference over here. Each of those has a type feature, inventively. A list of properties, which you can add stuff to if you want to. And that's where you should throw any extra properties or information or data you want to add to these should properties list. And then the second object in each of these is the geometry, which is type polygon, a list of polygons. So this is just a list, one of these with every single zip code in New York. Okay? And I collapse the coordinates because that's like a list of lat long for every vertex in every direction. Yes? That's an excellent question. So here is an amazing map of New York City. It is there. This wasted way over an afternoon of my life. What the hell is going on? So eventually I said, okay, let's inspect element. Let's see if we can actually find the SVGs on this page, because I'm sure as hell doing all the D3 stuff to add SVGs to a group. So sure enough, I right-click, inspect element. Here's the SVG. Nicely displayed on the page. There we go. Here is the counties group. Okay, that's smaller than I expected. And here's each individual zip code. So here they are, all the different paths. They're all there. They're just very, very small. So can anybody think what might have gone wrong in this nice little example? We do have a projection because it doesn't know where to put them. The default projection for D3 when you don't tell it what projection you want is Albert USA, which was the entire USA ocean. So all of the example D3 maps that you look at, or the majority of them, load up a beautiful map of the states, and it even has Hawaii in a nice place, Alaska's pulled down. That's not by magic, that's because the default projection is that. So this is actually exactly right for a projection of New York if we got rid of everything else in the USA. Now, I don't know how you guys felt about the shutdown of the last couple of weeks. So that is New York. It is there. It's just far too small to render. It is also filled with white, which is exceptionally useful. So that's where the map went. It disappeared. What you need to do is set up the correct projection for any map that you're looking at. And so the place that we do this is D3 conveniently has a load of pre-built projections, and it seems that Mike Bostock and a bunch of GIS guys got really enthusiastic about this. So I would be surprised if there's a projection you want to do that isn't in there somewhere. Definitely before you even consider doing matrix transformations and projection algebra, make sure that somebody actually hasn't done it before. Because thankfully most of that heavy lifting is being done. So in this case, the projection is d3.geo.albert.usa, that's the default. And this was, in my case, a set of trial and error to find the scaling and translation, which actually puts New York City in the middle of your map. Okay? You can have this for free. Right? This is hours of your life you never need to spend trying to identify where New York City should fit on your screen. The Another cleverer way to do this is to go onto the D3 Google Groups list, say, what's the light projection from New York City? And then Mike Bostock jumps on and says, oh, it's this, which is the other way I did it after doing this. So the second light, which is the correct D3 way to do this, is to do a conic conformal. And that is the light projection from New York City. Setting up specific parallels, setting the scale to bring it into the middle of your map, and then rotate it. The rotation coordinates here are the latitude and longitude of New York City. So if you have any other regional map you want to look at, that's the line you want to change. Okay? That's the thing that will actually get the map projection centered in the right place for you. Find the lat long you're looking for, stick it in there. And that will parallels. I think that's exactly to conic conformal. That's the bit where he just said, oh, do this. And I just did it. Didn't ask too many questions. And then what happens is, whereas before we just had path equals d3.geo.path, that lovely piece of magic that just takes a GeoJSON and turns it into a nice SVG outline. Now what we're doing is we're appending to that a specific projection. So that's changing the projection call within the path. And so that now takes our GeoJSON and it turns it into the correct SVG element to put in the middle of our screen. That's that piece of magic there. So that gets us to this, which is much more successful. So that is New York City. Nice familiar, it's in the middle of our screen. Because I'm adding data to this, that's why the colors are all blue, the outlines are lighter than before. But we can actually now see the city in each of those elements is its own individual SVG. And as you might expect, we just go there, click inspect elements. Here are all the different paths. So this string here, which says like D equals M271, blah, 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 that's what's being created when you have that attribute D path call. It's actually writing that string. That's what that does. So that's what the SVG element looks like. Okay, any questions at this stage?
Why is that secondary?
It's slightly more general in the case that, in this case, I kind of challenge anybody to derive those two numbers. But in this case, what's doing exactly the same work is just putting in the latitude and longitude in the symbol point you're looking for. So this is the one I would go to if I now want to do a map of Canada or a map of California or wherever. Yeah, and then I just put slightly to click around to make sure I actually get on the screen.
So, where your silent is going, is that kind of like?
And for this?
Yeah, so is my silent is still
Okay, so this should be index 3. Yeah, there we go. So, yeah, so I've now renamed the zip codes to zip code, and there's now some styling on here where the fill is really bad. So there we go. Okay, we have a white stroke on the zip codes. We set a nice join type for the stroke line join. That's irrelevant. You can ignore that. It'll still look pretty. And then I've just set the fill to be a mid. That's really all that's happening here, and this just means that every single zip code is filled with the same color. Other than that, that's the entirety of the map. Okay, it's even shorter than it was before. And now you have a map of New York City. Okay, but what we actually want to do is tie data to this. And so this is now going back to some of the stuff we were talking about earlier. What I'm doing here is I'm just going to take the area property that we have on the JSON. So go back to what the JSONs actually look like. Here we have object ID, zip code number, the name of the zip code, the state, the county, 2 New York City codes here, a building zip code, and then a shape length and a shape area. And now what I want to do for this particular example was take something which was a smoothly varied set of numbers, just because it's easier to plot data against numbers than try to identify things with it was. We could equally have just done a call on this to say, is it Queens? If it's Queens, make it red. Is it Brooklyn? If it's Brooklyn, make it orange. So you can query any of these elements that are in the properties and set your colors off them. Okay, in this case, my decision was I was going to do something nice and straightforward because what I want to show is using a number to set a color. So we're taking shape area is what's being called in here. And I played around with the normalization a bit to get a reasonable set of colors. In this case, normalizing the shape area by 1,000,000 just happened to be the right number to throw in. There is a D3 max and a D3 min function. You can use this to dynamically find out the ranges of your data and therefore accurately and dynamically set the normalization if you want to do this properly. I highly recommend doing that when you're doing something like. So here we write a get color function, and the get color function takes this wonderful letter D again.
Could you repeat about the normalization?
Yes, so if you have a list of data sets, you can call D3 max and D3 min to get the maximum and minimums, and then that will allow you to say, this is the total range, therefore I can normalize it. And you can also use, D3 has a bunch of scaling routines in there. And normally you would use for something like, say, take a range of X values, map them onto a pixel width that is the pixel width of my graph. You can do exactly the same thing to translate a value on your data to a number in a particular range that you're looking for. In this case, when you're dealing with colors, that's usually 0 to 255. So if you set up a D3 scale, it goes from 0 to 255, and you bring in a data value into that, it will always map it to a reasonable color value for you.
Thank you.
Yeah, that's a handy trick actually. So what we're doing here is I take a ratio, say if the ratio is greater than 0, return a D3 HSL. So HSL here is hue, saturation, and lightness. So the three terms there are the hue, which is like red or green or blue, the saturation, which is how close or far away from gray it is, and lightness is just how close to white or how close to black. And in this case, hue ranges from between 0 and 255. I think, I might be wrong about that, it might actually be 360 degrees. Saturation is 0 to 1, lightness is 0 to 1. So 50% lightness is slightly below 50% saturation in this case. And then the ratio is just being brought in from the data set here. So it's the shape area divided by 1,000,000 to give you a number which is somewhere between 0 and 255 because that just worked. And if it doesn't hit that statement here, return light gray. This was because when we were doing the energy zip stuff, we had a bunch of zip codes that we didn't have data for. So that just meant that we plotted those in gray to make it nice and clear which things were not being plotted. And so then this just gets tied into the function ready call. So we go back to the point where we plot our map. Now instead of just saying fill red, it's now style fill a function call where function D, again remember that's pulling in each of our individual data elements, and then we're just returning get color D. Okay, so that just returns a color. So for every single one, call the function, return a color. You're done. And this means that we will have a plot that looks something like this. So the color is tied to the area of the SVG. So thankfully, this works. So you have nice big green areas in Staten Island, you have small blue areas in Manhattan, you have kind of these intermediate regions here, possibly kind of a yellow ochre color. And you can immediately see how you can tie that to any data structure at all, and it will give you the color. So that's exactly what's happening here. You can see all the same bits at work. Okay? And what we did for the energy zip one is that there's a drop down. The drop down just says on change, recall get color, and there's a global setting saying this is the parameter you want to use to set the color to. That's it. It's just recalling that get color function on every element. And as you can see, that gives you a nice, pretty animation, which is really easy to get hold of. This gets you a long way to have a nice interactive visual map. You don't have to set the color scaling to the hue, you can set it to the color density. So you can just say, I want this to go from white to red. You can set the opacity, you can set all of the other properties that you might want on each of these SVGs. Okay? You can set the scaling factor on each SVG individually, so you actually have bigger states because you have a bigger number associated with it, and smaller states, all placed at the same correct center point. So this is exactly how you would do all of that timed data, which is where the map suddenly becomes useful. But if all you want to do is do a kind of a mapped out histogram of some variables to do in New York City, this is the best way to start. All right, any questions at that point? Yes.
Oh, this is a small thing, but for style, you can pass get color directly instead of wrapping it around this function. So it would just be style, quotation marks, fill, comma, then get color.
That is an excellent point. Yeah. Okay, yeah, no, you did right. Let's do that quickly, because that's an excellent point. So the argument here was that here, because what we're really doing is wrapping the get color function, and that's a large amount of duplication. And what you can actually do, it's not that much, yeah, you can actually just do this. And it knows it's a function, so it therefore passes the data objects as long as the function is constructed correctly. So it takes the data object, it returns the data. And of course, it is live editing code in a session, so it worked. Probably the first and only time that will ever happen.
Maybe asking this wrong, but can D3 be managed by jQuery or like some other language? So if you're passing parameters, values, and which way to do D3?
Yes, so you can set a listener with jQuery. So you can set an event listener with jQuery triggers on a particular case. And in that function, you can then run a bunch of D3 commands. You can absolutely do that. And vice versa. So you can actually set event listeners in D3, and then inside the D3 commands, you can run jQuery. So they're basically two parallel libraries. They do a lot of the same stuff. They're just jQuery is much more optimized for a lot of the standard DOM manipulations that you're used to, and D3 is more associated with getting into the data structures that are attached to that. I tend to use both because you can remember some things in jQuery which I can never remember how to do in D3 and vice versa. They play very well together.
The JSON structures in the two examples are quite different. So
Yes.
is there a reason how we design on structure?
So the Bostock example I started with has a topo JSON, which has a particular data structure style to that. It's useful and nice and compact, but it's really not common. So the reason I'm using GeoJSON is because it's generally easy to build or find GeoJSON out there. It's really rather rare to find topo JSONs.
Do you do them the same way?
No, I'd rather not build a topo JSON from scratch myself. I don't have to.
Not the tools
I'm sure they are. I just haven't got them at my fingertips, so it's much easier for me just to put together GeoJSON work. Yeah.
Right, so like you were saying, QGIS, right? So that can export GeoJSON.
Yes.
So not so much stuff.
I don't think so. I haven't actually. There's been a couple of updates recently. It's possible they started building that feature in. I don't know. I just haven't.
From the point of view of D3, you're just loading JSON.
Yes.
Just happen that you know they topo JSON or GeoJSON.
Yeah, I mean, it knows the structure of features and geometry. There has to be a geometry element of each JSON object for it to be able to figure out how to plot it. So the geometry elements of the JSON on each one, which has a list of lat long pairs, that has to exist. If that's not there, it will totally
And
fail.
that's in both GeoJSON and topo JSON.
Yes. Although the exact formatting within the topo JSON might be different. So if you notice in the first example, the Bostock code uses a topo JSON.js loaded in as a script at the beginning, which is going to be doing the parsing of the JSON. Whereas I just removed that all when I went on to do the D3 stuff with GeoJSON.
But
Yes.
isn't the only thing it's actually looking at like when it's actually mapping out these from that.
Yeah, so as long as it can, once you've constructed the D object, you're fine. And if you can write a parser, which will take whatever crazy JSON structure you're using and write a D element from that, then you're good. Okay, cool. So the last part I want to talk about with this map is that because we have the data structures, all those data structures are now tied to every single element, we can now get hold of that information. So we can actually build nice little interactive mouse over widgets. So you can look at your zip codes and you can see what those zip codes are. So this is actually laughably simple, which is I assume this is going to be particularly difficult and real pain, but actually it's nice and straightforward. So all that we're doing here is this is a div. Straight up HTML div. Right? It's 50% transparent background, black with black outline and some text in it. The margin top and margin left are being set dynamically. And there's an on-mouse move command, on-mouse in and on-mouse out on every SVG element. Okay, so all classic JavaScript stuff that I'm sure you all know right in the back of your hands. We're just tying this to D3 here. So everything up to here is what we've already talked about. The last two things are on mouse over, call the mouse over function. On mouse out, call the mouse out function. And then the mouse over and mouse out functions are pretty straightforward. So when you mouse over an SVG, you actually get the individual element as the argument to the function. So just like saying call function D with ... So you see here that mouse over is defined and it takes an argument. That argument is the data object that's associated with the SVG. Now that's where you start seeing the real power of D3. You don't have to like call some crazy jQuery string to find the ID that you remember structure in a particular way to get the element to then go in and find the data stuff that you tied to all that way back 3 months ago and you've forgotten the syntax. You know that the data associated with the SVG, not the SVG, the actual data associated with it, will be passed to any function on that server. Okay? This is hugely useful. So you can just store things on your DOM elements. You can leave them wherever you like and it will find them for you. Brilliant. And so here we set the text to d.properties.zip. It's just the zip code that's associated with every single one of these. And then we call jQuery in this function to say, find the mouse over classed element. In this case, this is an inventively classed div. Have the class of mouse over it. It should probably be an ID because there's only one of them. And set the text to be ny zip code. And then set the display to be inline. So basically we're taking the display from none, which is what it's set up to be displayed inline, so it appears on your page. On mouse out, I can be removed because that's no longer used in this. Remove the text in the middle of the div, and set display to none. That's it. So when you move out, hide it. When you move in, display it. And then the last thing is the place where the find the mouse coordinates comes in. So in this case, this is D3 select, find the HTML element, which is the whole HTML document, and set an event listener. So every time you move in the document, D3 is listening to it. On the mouse move, take a function, just basically get the locations of the mouse, so D3.mouse, and you pass in the this, which is just the event object itself, and that gives you the mouse coordinates. So this is just the x and y pixel coordinates of the mouse. And so add some padding because we don't want it to actually sit on the mouse. Then set the left and top margins of the div from those parameters. That's it.
That's a location in the whole page, not in the SVG.
That's true. So what you would do instead would be to, rather than setting the listener on the HTML element here, you would set it on the SVG element. And that will only give you mouse locations when you're moving the mouse over the map. So that'll set your locations, and that allows you to have the dynamic mouse over stuff.
Sluggish thing, dragging the mouse over it.
Yeah, there's a little bit of lag on that.
Is that because it's passing the
So let's just have a look at the
that seems
yeah. This should be the same code, so, but that's also one here. So you're welcome to pull that down and see if you can figure out what the difference is. Yeah, there's actually more on each of these zips here than on the other one. So it's passing a larger data object like for this one. So it's not that. So in this case, this is exactly how you can mouse over for that. And you can see that the data here depends on the version of the map you're looking at. So in the bit where it says populate the text, when you mouse over, you can put a switch, effectively a switch statement, and then say, if it's this mode, pull this parameter, if it's this mode, pull this parameter. That's all that is. Yes?
Is that that you don't have to set like the Z level on that? That it's like the SVG, or is that just?
So the CSS styling on this, yeah, I'm going to run the CSS on to get it to. Yeah, so there's a position. This is the styling on that element. So there's a position absolute set on there, which means it should sit above the SVG. That may depend on exactly where it's defined in your HTML body, whether it sits above or below, but you can always either set it as the attribute or just move it around to where you define it. Yes, that's all of that. Great, okay, so the last thing that I'm going to talk about before I hand over to Jeff is changing this and taking it to be, there's the mouse over box. Yeah, that's all of that. Okay, so we want to have a map that moves around. So that's the last part of this. So here's the same map, but now when we click on the location, it zooms in. We click on the zip code, it smooths the pans. It should, it'll pan around with nice smooth transitions. Okay. So to do this, there are lots and lots and lots of different ways to do this in D3. This is the way that ends up for this particular problem having the least lag. And also I didn't want to tie to the scroll wheel, just because you end up blocking all other scroll events with that. And in the case of the zip code app, we actually want to be able to scroll down, enter the details, see a bunch more page. So we didn't want to just hook up to the scroll element. Also, as soon as you start tying to scrolling elements and you also have mobile devices, that's a real nightmare. Okay, so for this one, this one I have to concentrate a bit more. Right. The workflow of this was that the zooms would happen when you click a zip code. So you click a zip code, it zooms in. So we need a click handler. That conveniently is on brackets click. Again, job done. You set a click function, it passes in the data element you clicked on, you're 90% of the way there. The function here looks a bit more complicated than it actually is. Basically what it does to start off with is there's a global object which has been created called center, which basically is, are you already centered on an object? Or which object are you currently centered on? That's more accurate. So you click on an object, it passes that object in here. It says if you really did pass in an object, that's the first check, and if that object is not equal to the one that you think you're centered on, then we need to move. We need to go and move the map somewhere else. So that now sets the centroid to the center of the thing you've clicked on. So what is the center of that? That's now going to be the middle of your view. Set the new x and y to the two parameters of that centroid. Set the zoom level. In this case, K is just going to be zoomed in 4 times. And set the centered object to the new element. Okay, so we're now centered on the new object. We know what the zoom level is. We know what the center of the view is. If not, then zoom out. Basically. So it's like take x to be like the middle of the screen, y to be the middle of the screen, and set the zoom level to be 1 and set the centered object to be 0. And then this is now to take a transition between I know what our new center is, we now know what our new zoom level is. Having calculated those, we're going to run an SVG transformation. So what this does is it sets the transform attribute of the group of SVGs. It's not transforming each one individually, it's transforming the entire group of SVGs. Trust me, this is a hell of a lot quicker than running any transformation on individual elements. If you try and do it on individual elements, you really don't need a lot before it starts really hitting the performance problem. So try, if possible, to run the transformations on groups of elements, not on each one individually. There are some examples on boss.com where he does do it individually. Yeah, trying to optimize that is a nightmare. Okay, but transform here, it does a translation, it then does a scaling, and it does a final translation. There's a bit of kind of black magic in there, but if you stick with that syntax, it'll work. And then in this case, I reset the stroke width. Because we're scaling the whole thing, even if it's set to be a 1 pixel stroke, once you're zoomed in, that's a 4 pixel stroke, and it doesn't anti-alias nicely, and it'll look like it. So you have to reset, rescale some of the styles because we're transforming the whole object. If you're transforming the individual elements, each of those would keep their internal stroke level. But in this case, you have to do that just to keep it looking nice. Yeah.
That's something I mean where it's too much takes around that using groups, but it's still sort of choppy.
Okay.
And I read that algorithms are not hardware accelerated, so it's actually thinking about like redoing the whole thing digitally. It's worth it because then there are the
Try it and see. If it's only 5 times, then and it will hardware accelerate it, then you're probably all right. But in one case, we're doing the map Pluto data, so that's an act like more or less for every building footprint in New York, and it was trying to transform every single vertex of every single SVG individually. Yeah, that died.
Is there a right system line?
So for the New York City zip codes, which isn't that many, but there are, you can kind of look and see there's a bunch of vertices in there. It's fairly fine-grained when you get up like around here, around the coastline. There are enough vertices in here that trying to transform individually will kill you. But as with other things, try it, see if it fails. At least know that there are other ways to do it and other approaches to take. There's a set of zooming and panning tutorials on the Boss.com list. It's hyperlinked from the meetup details for this group. So there's basically 4 or 5 different ways to do this. Run through them, see which one you might want to take a shot at. But have in mind that's where the complexity comes in. Depends what the object is that you're taking the transitions on, and that's where you're going to be paying attention. Okay.
Do you end up having a quarter pixel?
So you're always scaling by K, and you always have a stroke width of 1 over K. So if you scale up by 4, then your stroke width will allegedly be a quarter pixel, but it also does the scaling transformation, so it will end up killing it. Because as I said, it scales the whole thing, so you've already scaled up by 4, so you can do that nicely. And thankfully JavaScript waited to the very end before deciding that this should really be 0. Right, and then there's the panning. So that was just the click to get a zoom, the click to get a zoom back out again. And panning, in this case, because it was a very self-contained app, this is all held in global elements. You can and should set up a nice namespace for your map and tie it all to that. And be better coders, but I wasn't. So this basically keeps an eye on what the X and Y are and what the change, the DX and the DY are when you're panning. So what the mindset here is when somebody moves the mouse and is dragging, you set up a kind of a delta X and a delta Y that's being changed in that movement. Keep track of those and add them all to keep moving your map around. So that's what these are keeping track of here, some DX, some DY. So we set up a D3 behavior. This is invented on drag, call a function. The function is called dragging. Again, that doesn't need to be wrapped in the function call, but it's for now. And then we set up on the whole SVG to call the drag operation. And it happens. And then in dragging, what we're doing is take the D3 event dx. So it goes into the event and finds out what the dx is for the dragging event. And do the same for this. Scale it by whatever our scaling factor is, because we may be zoomed in. So we want to know about that when we're calculating the distance that should be moved. Add those dx and dy to the running sum. Increment our x and y by that total dx and dy. And then set the transform attribute of our GL. So every time we do this, we're just setting that transform element from scratch. So the transform element itself won't be incremental, you're not just appending transformations on, you're resetting it totally, which is why you need to be doing the sum of the total movements, not each one individually on its own. That's the reason for that. Yeah, so that gets you minus x and minus y, which gives you the context and allows you to have your nice hanging. So this gives you that. And this actually, because you're having the entire group, this actually doesn't really care about how many things are inside that group. The zooming doesn't always work smoothly when you start adding on lots more elements. The panning is actually remarkably stable against complexity. So we're done. So we have an interactive map. We can tie new data, arbitrary sets of new data to our data structures. We can zoom, we can pan, we can color our map using those data structures. And you can shift bullets down, take shots at it, edit things, change the colors, change the data sets, tie it up to any other zip code data set you might be able to find in the data portal. Go to the page that has Pluto on it, that also has all the electoral boundaries, the school district, all of it. So you can pick any of those, either turn it into a geoJSON yourself, or send me a note saying there's this particular set of outlines that I want in JSON. Please can you just send it over to me, because I don't want to go through the pain of installing QGIS on my own machine. I understand, I will do it. It might not be immediate, but I will do it. And now I'll hand over to Jeff, who will do some of a chat about adding in Google Maps under this. Any questions before we turn it over? Do the last bit? Yep.
These slides will be online.
Slides are on GitHub, and there's a link to the GitHub repo on the meetup, and so you can just download the whole zip file, which has both sets of slides and also all of these individual pieces of web page that I've created. Cool.
All right, thank you. So let's see, so I'm going to show you how to link up D3 in Google Maps, right? And so first, why would you want to do this, right? So part of this is just to show off that there's alternative ways. Like when you're working with D3, there's more than one way, to skin a cat, right? It's a very versatile application, API, and there's a lot of ways to get things done. Depending on what you're doing, maybe you want, a map outside of your data. Maybe that can be useful. So this is New York City. We're all New Yorkers. If you show us this, we know exactly what you're plotting. But if you're plotting, some congressional district in Ohio, yeah, maybe no one, maybe people aren't going to recognize that shape. And it's good to put it in context. This also gets to sort of your question on performance. Right? There's also times you don't want to do this. So, right, so this is plotting the exact same data that John was showing off earlier. So we can zoom in, and we can wait, right? There's a big lag here, right? So if you're plotting all the zip codes in New York City, you're starting to push the boundaries, right, of how much data, how many vertices you can plot. Right, so each time I double click, there's a lag. Actually, maybe I should make that more vocal. Okay, so right now, double click. And now here it is. So there's times, when this can be nice, and there's times when you don't want to do this, right? If you have a ton of data, we need to plot it fast. maybe adding Google Maps to it isn't the best one. With that being said, it's possible, so why not?
I'm sorry, when you just did that, were you going back to Google server or were you bringing over Google Maps?
So there's API calls, right, to serve up the Google Maps, just the standard Google Maps API. But other than that, everything's running on JavaScript.
Right now, when you're
Oh,
going
oh.
out to the Google, no, part of that lag was going out to Google.
No, actually, all of that lag is just D3 computation.
Okay.
Okay, so D3 plus Google Maps. So now the first sort of issue is styling Google Maps, right? So you can see from this sort of picture, right? The colors for Google Maps are designed to tell you where you need to go, right? What you need to do to get there. Great for readability, but it's horrible to plot over. So we want to be putting, shapes that with colors that are transparent on top of this map, right? So this blue shape has a big green patch in it, it's Central Park. This red patch has, a blue lake, a green park. This has roads crisscrossing through it, right? So the first thing is we need to clean up what Google Maps gives us, right? Make it much simpler. Fortunately, this is really easy. When you call in the Google API, it's highly customizable what it gives you back. And there are style sheet effects that you can use to, for example, remove labels, remove icons, and change all the colors. So, okay, so there's basically, you can just go on Google, type in Google Maps Style Wizard, yeah, and you'll get a couple of different options. Okay, so this link, the first link will take you to the Style Wizard that's hosted by Google. Right, looks like this. I'm not a huge fan of this one simply because the interface is for some reason by default kept small. So you have to like scroll over whenever you're going through the options. The better choice is number 15. Okay, so what this thing does, right, is it lets you change, right, this basically helps guides you in changing all the style elements that you can when looking at Google Maps. So first, let's sort of get into New York.
Well, this actually is kind of good. This, what we're doing is actually two.
Okay. So first thing that always bugs me is the roads. So I'm going to select feature type roads.
Okay, so
We'll select the geometry, the fill, change the color.
I actually think I don't really
I want set all the roads just to and okay, run through this so we can add. Yeah, and basically what you do is you poke through here, find what you want to change, right? So let's say we go to administrative, remove all the administrative labels. All right, so you go to visibility off. That gets rid of like all the neighborhood labels, like that. And then when you're happy with your selection, you click add. Yeah, and so this is just to show you, this tool exists. It's pretty easy. It holds your hand as you go through and style your Google Maps the way you want it to. And then when you're done, you can just click on Show JSON. Yeah, and this is what you want to pass to the Google Maps API to make the map in your web page look like what you drew using the style wizard. So when you're done with that, basically this is the original Google Maps. You can use the style wizard to clean it up however you like. For this application, I chose to make it really white so that the colors that represent the data you're plotting really are visible. So now that we know how to make it look pretty, how do we do it? So linking Google Maps and D3 is actually really easy. And that's because, as John showed you, that plotting a basic map is pretty easy in D3. What do you need to plot a map in D3? All you need is a div to draw it in, and something that handles coordinate transformation, or some knowledge about the coordinate transformation you want. Both of these are provided by the standard mapping APIs, right? So Google Maps, Open Maps, they can give you overlays, an overlay div that you can draw in, and they can all tell you how to translate a longitude and a latitude into an X and Y in your div. So D3 and Google Maps plays very nicely with each other. It's easy to link the Google Maps projection to a D3 path. And then after you're done linking the projection, you just do a standard D3 drawing method. And then obviously Google Maps handles all the panning as we move forward. Yeah, and then just here's a nice little tutorial. So here is the basic plotting flow that I'll be going over on how to link D3 with Google Maps. The idea here is I'm breaking up into things you do with Google and things you do with D3. So on the left column here are the blue things that you do with Google, the right are the things that you have to do with D3. The first step is basically just to create a standard Google map. Then you want to give Google Map to give you back the overlay so that you can draw on it. In that overlay, you'll then create the D3 SVG elements. You'll go back to Google, get the projection, and then you'll go back to D3 and do the standard D3 plotting map. So I'm basically going to go through each one of these steps and just give you the basic code snippets that'll do it. So the first step is to initialize everything. So here is the code that will give you a standard Google map. Right? So there's very little D3 here. I use a 1 just to find the div that I want Google Maps to draw into. But you could use, jQuery or anything else to select that. This is the standard Google Maps API call. There's a few options here. So, when it comes to centering your map, you just give it the longitude and latitude, and Google will automatically use its projection and make that the center point. Now, the style sheet that we went through with the style wizard to give you back code, you store that into a variable, and you just pass it to Google using the set options. Yeah, and then that automatically makes the map look like how you do it. So now we have our Google map stored in a little variable. This is what we use to create the Google Map overlay that we're going to draw into. Right? And this is once again all Google code. So we just create a new overlay. Right? Now the onAdd is basically what happens when you assign it to a map. So this is basically just another initialization function, which is actually just down here. Overlay draw. So there's a draw function for the overlays, and this is called whenever anything needs to be updated in the map. Right? Whenever you're panning, whenever you're zooming, it calls this draw function. And then you just set up the map, so you just assign this overlay to work with the map that you created earlier. Now here's where you start the D3 code. And basically, all you're doing is you call up the overlay, right, which you created above. You get the panes, and if you get the mouse target. So this is basically a little bit of Google code here, but you look at the overlay, and you ask it to return you a div that can listen to mouse events. Right? If we didn't get the overlay mouse target, then we wouldn't be able to do all the on-mouse overs, on-mouse click things. We just wouldn't be able to call it D3. And then you just do the standard D3 initialization, right? You create a div, you create an SVG, and you create a group. Simple as pie. Now drawing. So here you can see we initialize the overlay to have a draw function, which is this GM overlay draw, which is right here, this function here. So the first step is to get a projection from Google. Then we need to set up our path. Right? Now, what we pass to D3, right, we say use this projection, and the projection is a function. Right? This function has a parameters called coordinates, and coordinates is just an XY pair, right? Just an array with two numbers. This function then takes the XY pair, which is going to be latitude and longitude, tells Google to convert it to pixels, right? And then returns those pixels. And there's an offset here that we can go over later. But basically it just returns the XY pixels that Google tells us. Right? And this sets up our path. And now after that, we have the standard D3 plot. right? So this is exactly what John showed. You get your paths, right? You add your data, you enter it, and then once after you've entered it, you just go through the standard plotting routines.
So maybe all of the data is plotted, but some of the data is plotted outside of the physical area.
Yeah. So that's a very good point, and that gives us the subtlety. This is exactly why you have this 4,000 here, right? So I actually make the SVG 4,000 by 4,000 pixels, or sorry, 8,000 by 8,000 pixels, because you're going to be drawing outside of the boundaries of the window. And if that happens to, if you try and draw something outside the boundary of the SVG, it becomes very unhappy. You can have all sorts of fragments that enter into your plotting area. So you want to set it nice and big to accommodate whatever zoom level you want. I'm lost. Where is it? Oh, there it
Back on back divide.
is. Okay, so right. So as you can see, we have all the same events. Now, clicking. You can click and drag. Right, and you can also capture right mouse clicks. There we go. Yeah, so now we can look at a few details.
Oh, so yeah, okay. Oh, because you're capturing right.
All right. So very little has been changed from the basic code. Unfortunately, there's no color here. So okay. So basically, I just set up a new script. In the script, I set up all the global variables that I want to use. Now, here's the Google Maps style. So I copied and pasted what the style wizard gave me here. Very long. But basically, you just assign all that to one variable that you then pass to the Google Maps API. Here's the binding functions, the initializations. Here's the drawing. Here's the projection, and all this sits by itself in its own little script. Now we can go down here, and this will start looking familiar, right? Now here's where I just took the code that John wrote earlier. The only change is that the ready function, right? So after you loaded up the data, you basically save the data into this global variable, and then bind the Google Maps, and that's it. Any questions? Oh, yeah.
Did you end up filtering the amount of points you were using, or is it just the changing of the
This is-
styles that sped up the display?
Sped up the display.
The zooming and the scrolling, because when you were doing it at first, you showed that it was slow on the zooming.
So it's still going to be slow here. Yeah.
Oh.
Yeah, there's still quite a bit of lag. Maybe it wasn't noticeable like what I was doing before, just because I wasn't telling you that I was double clicking. So you thought that it was yeah. But with this amount of points, like this is sort of pushing the limits. Yeah, if you want this to be fast, you'll have to use maybe one row at a time, and it's quite fast. Or you can also, like you said, filter out the number of points. So find the vertices that aren't adding much information to it and trim those out. Yep, simple shapes.
If you do it just by, borough by borough, just say this is a thing for Manhattan, this is a thing for Queens. So you don't have too much data set.
Yeah, exactly. You can limit. Yeah, if you have a smaller data set, then limit.
I have some belief that there must be a way to do this. I haven't worked, but I haven't finished yet.
Yeah, I've been playing around with it. So I think what you want to do, if you want to have it, if you want to be able to do group transformations on it, right? So the reason that John's map is so fast is because he's not transforming each vertex, he's transforming the group. So what you need to do is create a bounding box for your data. basically create a group that is set up within that bounding box and then do transformations on it. The tricky part is zooming in, so you have to calculate what the scale is.
Yeah, because otherwise the Google Zoom and D3 Zoom transitions will be happening independently at the same time. And trying to keep those matching up will be a real headache.
I was able to get it to be pretty fast. I'm not using the zip codes, I'm using police precincts. But I ripped off the code from my postdocs on D3 with leaflet. And so I don't understand everything I'm doing, but I think that, I think it gets around this problem.
Okay, that's interesting. So if you do like a profiler on this, you know, when you're zooming in, 90% of the computation time is spent in the Google Maps projection functions, right? So going from a lat long to a div pixel. So maybe Leaflets has a more highly optimized than the Google transformation.
Well,
I'd be a little bit surprised.
yeah,
Maybe it's true.
the hard part of that with using leaflet is that in order to get the sort of New York City region, I had to make my own tiles. And so I've got a server making my own tiles. So like I don't want to pretend that there was no work involved.
In, let's say, Google Maps, you're not necessarily scrolling in a variable, they're increments, right? So are they,
Their steps.
so maybe, are they pre-calculating what, you know, there are only 10 gradations, they've already calculated what those 10 are? And so you're not going to go to 9.5, or you're going to get 9 or 10.
Right.
So is that part of why it might be faster? Because whatever level you're at, they have others already calculated, they have to calculate the next.
So yeah, Google Maps absolutely does that, right? So we have different image levels, or different, you know, image arrays for different zoom levels. But the D3 is then recalculating it every single time
So what
on the client side.
So what we were talking about before with K value, right? Is it, so if you would set K at just 10 different integers, right, and calculate those now,
What they are.
does
yeah.
that make it faster because you're just going from one set of numbers to another?
Yeah, so that's actually what I'm playing around with right now.
If you find the individual SVG elements using inspect elements, then as you pan around, you can actually see it transforming every single project number. So you can see it's doing it point by point in this case, whereas it doesn't actually find
So,
so if you pan around,
yeah, actually panning doesn't. So panning, when you're panning around, you're moving, you know, some higher level Google div,
which is why it's nice and quick.
which is why it's nice and quick. Yeah, but when you zoom in, you can see all these just changed.
So the leaflet example, it's using a way simplified shapefile of the United States, which is probably where it's
Yeah, there are a couple of pieces of JavaScript code out there that you can use where you can drop in a GeoJSON and it will simplify down shapefile for you. So, I mean, particularly in the zip code case, you can see there's a bunch of like tiny little zip code boxes here, which aren't actually zip code, they're PO boxes. And so you can get rid of all of those, and then there's a bunch of things which are like individual versions, which is the most useless of all SVGs. But there's a little bit just kind of scattered around here from the transformation from whatever shapefile into JSON. So there's definitely cleanup you can do on this. Cool, well in which case we shall wrap it up at that. I believe we aren't going to get kicked out of here for another 15-20 minutes, so please feel free to hang around. We already were invited to raid their fridge for Coke, so please feel free to take advantage of that. The two of us will be around for a bit, but also I put my Twitter handle up on the board. Feel free to ping me there. Or through Meetup, and please feel free to pull down the GitHub. We will play around and ask questions. Thank you very much.
So this is